And now let's go a little bit more into the actual Bayes theorem that we want to look. Okay, these are just a couple of important concepts that we need to look into. At the end, what we really need to check is this equation here, which is the one that we are going to be using later on in order to build the classification model or the machine learning model. We need to understand that this is going to be PH is going to be the prior probability. I'm going into more details and with examples in order to explain this in a minute, but let's define this as the prior probability of the hypothesis. Now we have the prior probability of the training data, because what we're going to be seeing is that we are going to be computing the probabilities for the training data in both outcomes. Okay, because well, in both or as many categories that we have, and then the idea is that we're going to be selecting the one with the highest probability, and we're going to be selecting the probability of H given D, which is the conditional probability, and the opposite, that the probability of D given that we know of H. Okay, so basically this is, I'm just trying to define this now, because we will be seeing this a number of times today. So we know that this is the probability of this particular situation, this is the probability of this particular situation, this is the conditional probability, the condition of H given that we know D. For example, the condition that D, we know that D already happened. So basically we know that this is D is going to, we know already the outcome of this, so, and then now we want to compute that conditional probability, and then the other way around. All we have to do for this Bayes theorem is to compute these probabilities, and then we are going to be seeing how we can, using all these probabilities, we can build a text classification machine learning model. It's not only for text classification. We can also build these models, for example, for the problems that we were looking into in the last lecture that we were using for the classification model for the k-nearest neighborhood. Okay. And we can also use this Bayes theorem also for regression problems, but that's outside of the scope of this module. Now we want to focus for a little bit. We want to focus in classification, okay, in the naive Bayes, and in text classification. I will be going into more details as we go. And basically, I'm going to start this with a particular example, okay, and basically, we're going to build a system that is going to tell me the sex of a person, given that we know the name. Okay, so let's assume that one person is coming into the room. Okay, and then we want to see, we don't look at the person. Okay, we don't look at the person. That person is telling me, look, my name is Drew, and then based on that information, I want to predict if that person is a male or if that person is a female. So all we know is the name of the person, and based on that, we want to predict if that person is going to be a male or if that person is going to be a female. And in order to do that, basically what we're going to be doing is that we're going to be computing all these probabilities. I will be explaining this in a minute. And with that information, we can compute the probability that, given the information that we have in my training set, in my database, given that information, what's the probability that if a person comes and the name is Drew, that person is going to be a male or that person is going to be a female. And the most likely outcome, that's going to be my prediction. Okay, and how that is going to be happening? Okay, Drew, this is just an example. It could be a male or it could be a female name. Okay, so we have examples of that. And basically, again, what we want to do is to predict what's going to be the most likely outcome given the information. Okay, we want to classify that person as a male or as a female, given that we have, okay, at the end what we want to know is what's the probability that this person is going to be a male, given that we know the name of the person. And we also, and this is the conditional probability that we want to do, we want to calculate this value based on the information that we have in the training data. And we are also going to calculate the probability that that is going to be a female, given that I know that the name of this person is going to be Drew. So basically what I will do is I compute these two conditional probabilities. Okay, again, it's conditional because we know a portion. Okay, we know this portion. We know that the condition of this is that the name is going to be Drew, and the name is going to be Drew was the outcome of the probability of male or female. That's all we want to do, and we are going to be looking with this into a minute. So if we use the naive Bayes theorem, what we have to do is we compute the probability of male, given that this is Drew, using the naive Bayes theorem. This is just basically what he was just mentioning before. It's just you need to be familiar with this with the theorem. All we have to do is compute the probabilities. Now, what we have to do in order to do this, we need to pre-compute the probability of Drew, given that is a male, the probability that is a male, and the probability that is Drew. And this is given based on the definition of the naive Bayes theorem. This information, we know that this information is given, okay? And all we have to do now is to compute all these probabilities so I need to pre-compute this information with the database that I have, and I'm calling that database my training set. Okay, so I assume that we already have a database, and that database we can compute all these probabilities. And that's the idea that how we're going to be doing. We do that for male, and we are going to be doing that for female. Okay, that's the key point here. So basically, the probability. What is the probability that of being called Drew, and you are a male? We want to compute that probability. We want to compute the probability of being a male, and we also want to compute the probability of using the name Drew in my database, because I also have. We can also have many other names. Okay, we can have Alex, Peter. Okay, we can have so many names. So these probabilities that we're going to be computing using the information in my database. Okay, in this case I'm doing it for male, but you will have to repeat this for females, and then we will be seeing which one is going to be the most likely outcome. And that's the situation. Okay, let's say that we are talking about an office, a police person. Okay, we don't know the sex. All we know is that this person is Drew, and this is going to be my database. Let's assume that we know all the Garda. Okay, we know all the Garda persons in Ireland, and this is the database that we collected. And based on this database, and that a new police person is coming here, so the Garda is coming into my room, and then the Garda is telling me, okay, my name is Drew. Based on that information, I want to predict if it's a male or if it's a female. And we know beforehand, we collect this information of the database of Garda officers in Ireland, and then we know that, for example, this person called Drew is a male, Claudia is a female, Drew is a female, Drew is a female. So basically we know that we have both alternatives. So let's start building these probabilities using the naive Bayes theorem. Actually, you will be seeing that it's quite simple. It's not really that difficult, and so on and so forth. Okay, all these names. So now what we have to do, we have this database. Now we are going to be using the naive Bayes theorem in order to predict each possible outcome, that the person is male given the name Drew, and that person is female given the name that is Drew. Okay, so let's start the process that we're going to be doing. We will be seeing how we can compute these probabilities using this information that we have. Okay, again, all we have to do is compute the probability for both outcomes, and then the one that is most likely, we are going to be using that one. So basically we know that we have to start with the probability of Drew. Okay, let's start with this one, and then we go with the other ones, because the probability of Drew is actually quite simple. What do we have to do now? We have to look for how many Drews do we have in the database. Okay, so we know that we have 1, we know that we have 2, we know that we have 3. 3 out of how many do we have? In total, we know that we have 1, 2, 3, 4, 5, 6, 7, 8. So we know that the probability is going to be that a person, the name of that Drew in the database is going to be 3 out of 8. Why? Because we have 3 Drews out of 8 potential candidates in my database. Okay, so we know that this is the probabilities. We know that we have 3 Drews and out of 8 persons or 8 candidates. So now we complete this portion of the equation. We need to complete that for all the other portions of my equation. And once we have all those numbers, we are done. Okay, so now we can continue with the probability of a male. What is going to be the probability of a male? Again, all we have to look is how many males do we have here? We have 1 male, 2 males, 3 males. So we know that we have 3 out of how many candidates, individuals we have in the database? We know that we have 8. So basically this is going to be also 3 out of 8 because we have 3 males in this particular case. So that's going to be this portion of the probability. So now we are only missing one particular one. We only need to compute one additional component of the naive Bayes theorem for classification. Okay, so we have 3 out of 8. Now what we have to do, these are the 3 males that we have out of 8 in total. Now we have to compute this particular part of the table. How do we do that? So now what we want to do is to compute the probability of a person that out of all males we have a Drew. So out of all males that we have a Drew, so we want to compute that particular probability only for, because this is the conditional probability, and we want to focus only in the males in my database because the conditional probability. So what we are going to be doing is that we focus only these ones, the ones that we have here pre-selected. Okay, so we have all these males, and we want to see from these males that we have what's the probability of the name being Drew. Okay, so we know that we have one Drew, only one out of 3. So that's going to be the probability, because this is the probability only of the males. What's the probability that we have a Drew? Only for males. And we only have one Drew here, so this is going to be 1 out of 3. And now we complete this portion of the naive Bayes theorem. Okay, so we will be seeing, again, this is just, we have 3 males, and we want to look at the probability of Drew of the males. And now we finish this part of the equation. So now we can compute if we compute all these numbers, or if we multiply these numbers, these probabilities, we are going to get the conditional probability that is going to be a male, given that the name of that person is going to be Drew. Once we compute that probability, we will have a number, and then we can repeat the same process for the females. That's still extremely important, so I will let you think about it. Okay, so if you want, you can stop the video, you can pause the video and try to complete yourself these probabilities. This is extremely, it's important that you start practicing. All you have to do is to repeat the same process. And what's going to be that process? Okay, basically what we have to do is that we have to start computing. Okay, so something important here is that look at this part. Okay, this part is going to be the same because it's the probability of Drew. So we don't really need to recompute that. That is already, we already have this portion of the equation. Now we need to compute this portion here, which is the probability of a female, and then the conditional probability. So if we want to compute the probability of a female in the database, all we have to do is that we look at how many females do we have. We have 1, we have 2, we have 3, we have 4, and we have 5. So that's going to be 5 out of, we know that we have 8 candidates, 8 individuals. So this is going to be the probability of a female. We are almost there. Okay, now what we need to compute is the probability of Drew given all the females. So of all the females that we have, what's the probability of seeing a Drew? That's going to be quite simple as well. We only focus in the females. We focus in this one, we focus in this one, this one, this one, and this one. And we have 1, 2, 3, 4, 5 candidates. So now we have 5 candidates. And how many Drews do we have? 1 and 2. So now we have 2 Drews out of 5 females that we have. And that's going to be the conditional probability that we need to compute in order to complete all the probabilities for the theorem. So we compute this information. This is going to be 2 out of 5. Something important here, this is actually quite important. Now that we really know that this information here, this portion of the equation is going to be the same for the male part and for the female part. So basically we can actually, if all we want to do is to predict the outcome of male or female, we know that this is going to be constant for both. We don't really need to compute that for this particular case in order to know the outcome if it's going to be a male or if it's going to be a female. If the question is asking, give me the probability, you need to include this in your calculation, because otherwise, if you only compute this part of the equation, you are not going to compute you are not going to compute the probability. Okay, it's just that when we want to compute the probabilities, in order to speed up the process and to avoid computing this value, which is going to be the same for all possible outcomes, sometimes we don't do it because we know that that's not going to impact the prediction, including or not including that. But if the question is, give me the probability, you need to compute that. Okay, just to it's an important point that I want to mention. So a number of times I don't compute this part. Okay, but actually here we don't really need to compute that because we know that this value is going to be smaller than this value. So with that, only with that information, not including this in the calculation, we know that it's more likely that it's going to be a female. So based on that information, the predictions that we are going to make once a person comes, and I'm not looking in the person, but the person is telling me, my name is Drew, so I want to look, I compute all these probabilities that we have based on in my database, and with that information, I'm going to compute, I can infer that it's more likely that it's going to be a female. In this case, we have two categories, male and female. But if in the future you have 100 categories for your problem, you will have to repeat the same process in order to compute for each particular person or category that you have in order to get the final model. And so far we have only assumed that in my database, in my training set, we only have one particular feature. We are assuming that all we know is that we have that the name is Drew. But in real cases, we can have more features, okay? And we can actually integrate all those features in the naive Bayes classification problem. And all we have to do at the end of the day is computing all the probabilities and start multiplying all those probabilities. And I'm going to be showing that in a minute. And important, when we do this naive Bayes method, classification method, what we are doing when we multiply all these probabilities is that we are assuming that there is a relation between the outcome and each particular feature or attribute. Okay, so basically we know that there is a relation between these two, the outcome and the features, and we are assuming that this is the only relation. We are not assuming that there are relations, that there is a relation between the features. Okay, this is an important assumption that the naive Bayes method is including in the model, which in real case is not really, we cannot always assume that. Okay, but in practice, when we apply these naive Bayes methods, assuming that they are independent, then that is still a quite powerful method. Okay, but you still need to take into account that the theory behind the naive Bayes methods is assuming that the features are independent, okay? Are independent and there is no relation between them. That's extremely important. For example, that there is no relation between the color of the eyes and the name, for example. That there is no relation between all the features that we have. Okay, but for example, there is not a feature, there is no relation between the hair, the length of the hair and the name. These kind of things. We are assuming, this is what naive Bayes is assuming. Okay, that's the assumption. But still, even though in multiple situations we know that that's not the case, we can still try naive Bayes because in practice it's very effective in many cases, even if we are not, if we cannot assume that they are independent. Okay, so basically what we are going to be doing at the end of the day is that we compute all the probabilities, okay, for all the possible situations independently, and then we multiply all those probabilities. I'm going to be explaining this with an example in a minute.